that's hard to do. It is trying to get a model to transition from that vertical to that horizontal safely and reliably and repeatedly is a lot of work. Yeah, so we're going to do that on a 3-foot model first.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
Today's episode is brought to you by our platinum sponsor, XTI Aerospace. They are powering the vertical economy, building a long-range VTOL, and you can find more at xtiaerospace.com. Now, please remember to like, comment, and share on this channel, and enjoy today's podcast. Welcome to the Hangar X Studios podcast. We're live at Verticon, and we are interviewing some incredible disruptors, innovators, industry leaders. And with that, we have Robert Lunnie on today. Robert, thank you for coming on the podcast.
Yeah, thank you. Thank you very much for having me.
Now, we met up in Grand Forks, North Dakota.
Yes,
you are part of University of North Dakota.
Mm-hmm.
You're a professor of aerospace up there.
Mm-hmm.
Retired Air Force,
Yes.
nuclear background, but now
Yes.
you're doing a lot of work with drones and unmanned aerial systems and the aerodynamics. You have a team up there. And it was interesting because we were talking to the people from XTI, and I know that they have actually been working with you to develop subscale models and prototypes.
Yes.
That they can just subsequently build and iterate, so they can get more and more better, gooder data is
Right.
what my good friend Len calls this.
Yeah,
right?
yeah, that's actually a technical term.
Yeah, it's a very
yes.
technical term. Yes.
Yep.
But what we'd like to do is, could you though talk about when you're actually taking a very mature drawing that's in a CAD/CAM system, that XTI has for their Trifan and many other people here that are developing products. How do you take that and map that over to actually creating a subscale prototype?
That's a great question. Yeah. So there's a couple different ways you can do it. Depending on if the CAD software, if we have access to that type of CAD software, we can pull right off of that and actually like 3D print a small model. We've already done that with XTI. My crew just the other day had some time to kill, and they thought they would make some cool stuff, and they actually printed out about I have to say maybe half a dozen to a dozen XTI Trifans about this big with the motor, with the tilt fan in different configurations. So they're all over the office now, and we play around with them in the office, and we have different colors and all kinds of cool stuff. So
that's fantastic.
Yeah. So if we have access to that, or if we don't, we actually can design our own using our own CAD software that we have. We use a company called Fusion 360. And we can develop it, transfer it over, or just redo it on our software. And then from there, again, we usually start with building a very small subscale model, about this big, and we kind of keep that as inspiration. We have that as we're doing things. We can keep looking on, what it's going to look like and try to envision that, but bigger.
Now, how do you take that the small model, which is fixed, right, and then turn that into something that where the different part moves the way you want, the center of gravity is like, so you could actually have, or is that kind of the first step? Like, first I'm going to test it, and then, kind of tell me the process, because it's fascinating to me.
For sure. So for this model, we're going to build, eventually it's going to be a 6 to 8 foot subscale model.
Okay.
But we're not going to start off with that. That's actually a pretty good sized aircraft, smaller aircraft.
Yeah.
So what we're going to do is we're going to build about a 3 foot subscale model first, and it's going to be laid out very similar to the Trifan 300. It won't have a body on it at first. It'll be just a frame, so it might be just some aluminum like square tubing, and you'll see that all the components are exposed. But we'll build that first and actually just get it to fly. We'll set it up so it can go vertical, so we can start testing the vertical capability of it, and then next we'll go into actually that transition where the motors are going to actually rotate over and go into horizontal flight. And that's hard to do. It is trying to get a model to transition from that vertical to that horizontal safely and reliably and repeatedly is a lot of work. Yeah, so we're going to do that on a 3 foot model first.
Now, a lot of drones now have the fixed propeller. So the way that I go into forward flight is I'm going to probably rev the back ones higher and get into a different attitude, right?
Yeah,
Exactly. Kind of like the way a helicopter does. So have you guys? How do you guys then take something a propeller and articulate it?
Exactly. So It's very the quad style. The quad rotor aircraft does that, right? It's almost like your basic drone you buy at Best Buy or whatever. If you want to go forward, the rear props spin up a little bit faster, creates more lift, and it just kind of moves forward, and everything adjusts really quickly with the flight controller. But with the XTI model, with that, it's actually a rotating nacelle. Like the motors are going to rotate themselves. So what we'll do is we'll do a vertical model first to get everything working out, like I said.
Yep.
And then we'll we'll start working on the rotation of those nacelles to actually get that forward flight. And for us, we'll probably have just some servos that are connected, and we'll run it through the flight controller and our ground control station to just start working on that transition phase to actually get it horizontal. Then once it's in horizontal, lift will come off the wing, which I always say lift off the wing is a wonderful thing. It's cheesy. I totally know. I'm going to put on a Valentine's card for all the pilots out there to give to their Valentines.
I'm sure they might use that for their new tagline.
Right? Yeah.
They
Lift off the wing is a wonderful or beautiful thing. Yeah. And so are you. That's
and so are you. That'd be the Valentine's version.
Right. Exactly. Yeah. So that's how we're going to do it. We're going to do the 3 foot first. And then we're also in concert with this. We're building a ground control station. So this is the part that I really get excited about is you can fly off the sticks, which we will, when we're testing the prototype, but we're actually building a ground control station as well, which will have monitors in front. It'll have joysticks on the side, and you'll be able to fly that aircraft from a seated position, like if you were in the aircraft. And I actually do research in this area myself at the University of North Dakota, where we built a small subscale model with cameras in the front facing forward and then one facing down. And that information from the cameras gets fed into the video monitors. So you actually fly it sitting like this, like you would actually be flying in the aircraft. Yeah. That's what we're going to do with this one as well.
Yeah, and talk a little bit about some of the capabilities that, UND Aerospace, everybody knows it's one of the largest flight schools in the country, not in the world.
Yeah.
And the simulator bays are incredible, but you guys have done a lot of R&D and actually developed that, like in conjunction with Cirrus and Cessna. And what are some of the capabilities you guys have in kind of that area? Because that could map then into a flight control system for a vehicle like this.
Yeah, for sure. So Grand Forks, North Dakota, first off, when people walk by our booth over here, if you happen to see it, you saw like 100 airplanes and, a bunch of helicopters, a bunch of drones. And people ask, twice today so far, is that CGI'd or is that Photoshop? That's an actual picture of our fleets. We are the largest flight school in the country. And we do a lot of operations, a lot of flights. So that's just a small part of the ecosystem for drones and urban air mobility and advanced air mobility. We also have the Gorman Test Center. We have the RISE, which is the Research Institute for Autonomous Systems. We've got, like I mentioned, like the Test Center. We also have an incubator like the Hive, which is just for drone companies. So we have this enormous infrastructure.
How many companies are in the Hive right now? I think it's over 20, 25?
I'm not sure. I'm not sure, but that sounds like a pretty accurate number.
Yeah, it's a great ecosystem for everything UAS, especially right there at the Hive.
Yeah, they have great coffee. They have cool.
They really do.
They have cool people. We really we go there and we work. We have an office working with XTI, and that we're helping XTI build their lab there. And then I also, for my company, have a small office there as well. But we literally go up there and just work, and it's just a great vibe. It really is. Like, people there work hard. They want to push boundaries. I mean, that's what it's for, right? Is to foster that economic growth in Grand Forks with drones.
Yeah, and talk a little bit too about the, Gorman Field is a kind of a unique area to test, prototypes like this. And then also you have Great Skies, which is actually up on the Air Force Base.
Yep, Grand Sky, yep.
And Grand Sky. And there are some really unique elements to the airspace up there.
We do.
Could you talk a little bit about that?
Yeah, so we have Grand Sky, and the major tenants in Grand Sky are Northrop Grumman and General Atomics. They're attached to the air base, and that's also attached to the ecosystem for testing as well. So companies can come up and they can rent space or use the facilities up there. For testing.
Yeah, it's open airspace. You can also get feedback from military radars, observability, ATC, ADS. I mean, there's just so many unique things about flying and testing up in that airspace that I think is kind of unique in the country.
It is, yeah. Some people call it like the Silicon Valley of drones. You know,
Okay.
it really, because it really is just such a robust ecosystem. And once you start learning about what we have up there, it's like a no-brainer to come up and do your development and testing and things like that.
Yeah.
And there's large scale, like I said, Northrop Grumman, General Atomics, big, large corporations. And then you got the little guys and gals like me. You just, a few interns just kind of pumping out cool stuff and trying to push boundaries as much as we can.
Well, isn't it Northrop that's refitting the what is the Global Hawk, which is a
Yep.
drone the size of a 737,
Huge, yes.
down to
Yep.
small palm-sized drones, right?
Yeah,
They,
yeah.
they got and everything in between.
Yeah, exactly. They're retrofitting the Global Hawks up there.
Yeah.
Yep. Yeah, they'll be called Range Hawks.
Range Hawks.
Yep.
And a question for you. So from the small drone that you have printed out on your desk to the 6-foot drone that
Yeah.
is now able to capture engineering data, right, for the CFD systems, for modeling, to take some real world data. I know other companies have used prototyping to be able to do this, to enhance their modeling. What is the timeline of a process like that, you think?
Oh gosh, that's a great question, John. It really, I hate to be vague, but it can vary. It really depends. That moving that from that vertical to that horizontal is a kind of, with a rotating nacelle is a feat. It's not easy to do. But it could be, 6 months, 8 months. It really depends on the project itself. But we're going to build the 3-foot subscale model and learn what we can from it, everything we can. We're not super concerned about longevity, how long we can fly, things like that. We're learning about that vertical to horizontal transition.
That's right. You can just keep printing new parts.
Yeah, exactly.
Right? Right. Yeah.
So we do rapid development with 3D printers, which we have up there, and we order a lot
You have
of
some pretty large scale printers.
Yeah, we do have some pretty nice printers up there too. So yeah, once we get that 3-foot model figured out and get that transition and everything set up, then we'll safely and comfortably move into a larger model, which will look like the Tri-Fan, which will have airfoils on it, and then we'll fly it on the wing. We'll get up into that transition and we'll fly it around on the wing and then transition back and land. So
one question as we wrap up. So because I'm curious about this as an engineer.
Oh yeah.
How do you gather the data from the prototype, and translate it so that it's data that the engineering team can use for the real full size aircraft? How do you do that?
So that's a great question. For our mission planning software, we can download all that data. We can download how much battery is being used. We can put sensors on it that'll get us our airspeeds. It tells basic information.
Airflows, all the power.
Yep, power consumption and things like that. And we can do good just aviation too, and just kind of like watch the aircraft fly, see how it acts. Like just good old school aviation as well.
So Robbie, as soon as we get this first one flying, we need to have you back on the. Maybe we'll even come up there and we'll film out there at Gorman Field. I've been there once before. So
come in the summer.
It's kind of in the middle of nowhere. Yeah, you definitely want to come in the summer. And man, just thank you so much for your time and just the work you and your team are doing. So,
Super excited. Thank you very much, John. Appreciate it.
Fantastic.
Yeah.
Thanks, Robbie.
Thanks.